So this is where we have an example of application, because obviously we learn about condensation polymers and polyesters, and for a polyester you would need a diol and a dioic acid, and that would give you the polymer chain. But here we haven't got that. We've got the diol, but we've got a single carboxylic acid. We've got ethanoic acid. So what we're making here is not a polyester, but a diester. And from that, what we can presume is that we're going to end up with two ester linkages within our final compound. So starting off with some of the working out, I've actually drawn out the two ethanoic acids and I've drawn out the ethane 1,2-diol. We can see here why it's a condensation reaction because we're losing the two H2Os, and we can also, by drawing it this way, see how the links are going to be made between the three different component parts that are going to make up the diester. Now from there, we can go forward and we can see that this is the diester that we are going to make. We now have an equilibrium question where we're going to be considering how to work out equilibrium moles, for example. And I'm going to go through this with a little bit of explanation as well, rather than just put the figures in. So there's a couple of really important points to note on here. The first is that we can work out how much our ethanoic acid has gone down by, how many moles less there are. We've also got the ratios from the equation, which is earlier in the question, which I've written up at the top, 2 to 1 to 1 to 2. Now, if we know that, we can then work out what the equilibrium amounts of all three other components will be. So, for example, ethanoic acid to water is a 2 to 2 and therefore 1 to 1 ratio. So if 1 mole makes 1 mole, the 0.29 moles of ethanoic acid used will make 0.29 moles of water. Slightly trickier on the two in the middle, and that is because we've got a different mole ratio. If we compare ethanoic acid to the ethane 1,2-diol, there's a 2 to 1 ratio. So if 2 moles of ethanoic acid react, only 1 mole of ethane 1,2-diol will react. And so it's not gone down by 0.29, it's gone down by half of that, 0.145, and that's where our 0.06 comes from. I can then compare my ethane 1,2-diol to the C6H10O4, which is a 1 to 1 ratio. And if I've used 0.145 moles of the ethane 1,2-diol, then I've made 0.145 moles of the C6H10O4. Then we move in to the expression for KC. Lots of things that you need to remember here. You've got to remember that products go over reactants. You've got to remember that the powers within the expression for KC come from the balancing of the equation. So it's H2O squared because it was 2H2O. It's CH3COOH squared because it's two ethanoic acids when you balance the equation. Now, we don't need to consider volume here, and that's because the volumes will cancel out. If you consider that the concentrations are actually ester over V, H2O over V squared, we've got 1 over V cubed on the top line. Now, if you do exactly the same on the bottom, we've got 1 over V cubed there as well. So they balance out perfectly. Moving into a slightly bigger calculation here, and you'll notice that you're not working out KC that's been provided, you're instead working out the amount of ethanoic acid. So I'm going to start by putting the figures in that we know to the KC expression, and And the highlighting here is going to help you to see precisely where they've come from. Obviously, this is rearranged to make CH3COOH the subject. Technically, it's the number of ethanoic acid molecules. It could have been the concentration if I'd included the over V's, but we don't need to. I put those figures in. I then rearrange to make n the subject rather than n squared, and that takes me to my final answer, 0.789. Now it tells us it has to be to the appropriate number of significant figures. If you look at all 4 highlighted pieces of data, they are all to 3 significant figures, so our answer is going to be to the same value. So you could do all of this hard work and overround or underround and then take yourself down to 2 marks. So always be very, very mindful of the appropriate number of significant figures if asked.